All right, learning target 7 for unit 2 is construct a linear equation given a graph. Okay, before we look at the graphs, I want to talk about 2 nice points. Okay, the biggest thing in writing equations from graphs or from points is just having 2 nice points. We talked about in standard form that really you only needed that x-intercept and that y-intercept, and you can draw a line through it. You need 2 points, and if your equation is linear, then those 2 points are all you need to find slope and then to find your y-intercept. Okay, so if we have those 2 points, and you're often going to hear those 2 points called x1, y1, x2, y2, just simply for the first point and then the second point. And then the slope can be found by taking the y2 minus the y1, and so finding that rise, that difference in rise, and then the x2 minus the x1, which is the run. Okay, and you can also see that as change in y, that delta that triangle means change over change in x, which is rise over run, which you've all heard before. So we're going to take a look at that on graphs today. So our first thing here is to find 2 nice points, and often on a graph, one of those nice points is going to be the y-intercept. So I just like to find 2 nice points, and what I mean by nice points is points where I don't have to do any approximating, any estimating of what the point is. So here, like at 1, I don't know what that is. It looks like 2.5 maybe, but at 2 right here, it definitely is 1. So I have 0, 4, and 2, 1. And then from there, I can just find my rise and my run. Well, it looks like I'm going down from 4 to 1, down 3, 1, 2, 3. And you can count boxes, but you can't always count boxes because it might not always be counting by 1. Each box might not always be representing 1. So I like to have these numbers here to be able to go down or to look on. And then over, what do I run? So that's my rise. I go down 3, and then I run 2. And if I check that with my numbers, 4 to 1 is 3, yep. 0 to 2 is 2, right. Okay, so my slope is negative 3 over 2. All right, so I have that much. Y equals negative 3 over 2x. Plus, I need my y-intercept. Well, I have it right on the graph. 0, 4, I start my line at 4. I cross the y-axis at 4. That's my answer. Okay, my line is going down, so I should have a negative slope. I can check that. I can make sure all those things are coming together. Okay, over here, again, I'm going to use my y-intercept as a nice point because it looks like a great point. And then this doesn't look great. This one, 1, 1 looks like a good point. All right, so then what I have here is I have 0, negative 4, and I have 1, 1. This is a good practice to get in, and hopefully I'll be able to show you an example of why in a couple seconds. So from 0, or from negative 4 to 1, I go up 5, so I rise 5, and then I run 1. Okay, so that's my slope. That reduces to just 5, right? So my equation is y equals 5x, and then my y-intercept is here at negative 4, so minus 4, or plus a negative 4. That's my equation. Moving on, I need 2 nice points. I like this point right at the origin, and then this point right here at 3, 5. I like it. So going from there, I have 0, 0, and then I have 5, looks like 3. Okay, so I go up 3, and I go over 5, so my slope is 3/5, rise over run, so we have y equals 3/5 x. Now, what's my y-intercept? If I cross at 0, my y-intercept is 0, but you really don't even need to know that, or to write that, because anything plus 0 is itself. So that's my equation. All right, this line's going down right away, I know. And so I know I'm going to have a negative slope, but I'm going to pick 2 points. My first point is negative 4, negative 4. My second point is 0, negative 5, it looks like. Here I go down 1, and I go over from negative 4 to 0, 4. So my slope is negative 1/4, and my equation is y equals negative 1/4 x. Looks like minus 5 or plus a negative 5. Getting the hang of this? I want to do one more here. I want to look at a graph of, like let's say where my y-intercept is going up by a different value than my x-intercept. Let's say that my y-intercept is counting by 3 or 4. So we have 4, 8, 12, 16. Okay, so I have that scale here, and let's say I have just 2, 4, 6, 8 here. Okay, so now if I draw a line here, and let's say I start at 4 and I go up like this. Okay, I'm going to have a different, this is going to look a little different than before. Okay, it's going to be a different kind of situation, and one where we have to really pay attention to what's going on with the numbers and not necessarily just what's going on with the boxes. Okay, so if I pick two nice points, I know I start at 4 and I have a nice point here at 216. So 216 and 4, 0, 4. Now, what would be nice here is that if I counted boxes, my slope would be 3 over 1, right? Well, because I go up 3 and over 1. But if we look closely at this, I go up from 4 to 16. That's a change of 12. So my rise is 12. I go over from 0 to 2. That's a change of 2. So my run is 2. My slope then would be 6. So what looks like 3 over 1 is not the case. So you have to be conscious of these numbers here. That's why I always like to write out my two nice points. I think it helps me to see that, okay, if I were just counting 3, I think right away I'd be like, wait, 16 and 4 does not have a difference of 3. So I think that would point that out to me a little bit better. Okay, so try that, or make sure you check that. And before class, I want you to draw 4 lines on the graph. Okay, so just get out a straight edge, draw 4 lines, label them y1, 2, 3, and 4, and then after you've drawn the 4 lines, draw some ups, draw some down, then write equations for each of the 4 lines that you draw. All right, so we'll have that for